Here it is, guys. Final lesson for 6.1 to 6.3, this unit. This is 6.3b, solving systems by elimination, carrying from our last unit, but now we're going to add a little bit of a twist with multiplication. So this method you can use for any single system you ever come across, okay? The objective here, solve a system using elimination involving multiplication. All right, but if you're given any system of linear equations, this method will be able to get you to solve it. Okay, so you have to still remember, in order to use elimination, you must align the like terms. All right, you want them in standard form, both equations. You want the x's above each other, the y's, and then equaling the constants. That's still the same. Okay, so in some cases, this is carrying on, like I had said from the last lesson, that you may need to multiply one, sometimes both equations, to make a number that you can cancel out, to make a coefficient, something that can cancel out. Okay, so here I'm looking at my x's. All right, if I look at them, can I add these two x's to cancel out? No. What about subtracting? Can I subtract? No, I can't do that. Well, then let's look at the y's. Can I add the two y values together to cancel out? Nope. What about subtract them? Nope. So it doesn't work. We're thinking elimination won't work because if I add or subtract these two equations, nothing gets eliminated. Well, we are allowed to do something called multiplication. We are allowed to multiply one or both of the equations in order to make one of the coefficients cancel out with the other one. Meaning, so let's look here. I have right here a 2x. If this happened to be a minus 2x, wouldn't that minus 2x and that 2x cancel out? Why, yes, it would. So if I were to multiply this by 2, I would get negative 2x and 2x, and they would cancel each other out. But the way it works, with solving equations, whatever you do to one side, you got to do to the whole side. So I can't just multiply one term by 2. I have to multiply everything by 2. So underneath this, what I'm going to do is rewrite this equation as if I were to double the entire equation. I would get negative 2x. Distribute here. I would get plus 6y. And I can't forget the final piece equals negative 24. So this top equation and this bottom equation in red is the same exact equation, but it's just twice as big. And now what I can do is I can use these two equations below the blue line to cancel out the 2x. And then I have y plus 6y, that's 7y. 3 plus negative 24 gives me negative 21. See, it still works out to be the same concept. Divide by 7, and we're left with y equals negative 3. So I have part of my solution. The y is negative 3. Now here's the part you can't forget. I have to now go back and plug this into one of my original equations. I have to plug my y to be negative 3 into one of my original equations. I don't want to use the red one I created, just in case I made a little mistake. I want to plug it into one of my original equations. And I'm going to look at my second equation. This y is all by itself. I'm going to use that one. All right, so I'm going to plug in 2x plus my y value, which I just figured out was negative 3, equals 3. And now I'm going to solve for x. I'll add 3, 2x equals 6, so x equals 3. I'm going to divide by 2. So my solution here is 3, negative 3. So I'm able to find a number to multiply by in order to cancel one of the coefficients out. Now this is where it gets a little bit more challenging. Here I'm going to identify here my x's. Nothing cancels out, 7 and 5. My y's, 12 and 8. Can I multiply 7 by anything to get 5? Nothing pretty. What about 5 to get to 7? Nothing pretty. Same thing with 12 and 8. So this is where that old thing called greatest common factor comes into play. What's the greatest common factor between 7 and 5? Go ahead, what is it? Good. What's the greatest common factor between 12 and 8? Good. Since the 12 and 8, since they're smaller, what I'm going to do is I'm going to multiply this top equation by 2. And I'm going to multiply this bottom equation by 3. Now, why am I doing that? Because that'll make my y's both a form of 24, which will cancel out. My top equation becomes 14x, because 2 times 7 is 14, minus 24y equals negative 44. My bottom equation, I'm going to triple it. That gives me 15x minus 24y equals negative 42. Now, if I look, my y values are identical. If they are identical, the way to cancel things out if they are identical is we need to subtract them. Don't worry about their negatives. In order to cancel two things that are the same, we need to subtract them. So what I'm going to do right now is put a subtraction sign between each of my coefficients. So I have 14x minus 15x. That gives me negative x. Negative 24 minus negative 24. That gives me nothing. It cancels out. Negative 44 minus negative 42. That gives me negative 2. Divide by negative 1 because I have a negative x on that side, and x equals 2. So I have my first part of the equation. What I want you to do right now is figure out, plug that in anywhere, and you tell me what is the value of y. We'll see. You either get it right or wrong. We'll find out. Here's another example. I want you to take your time on this. Pause. Oh, well, I'll give you time to pause it. And go ahead, figure out what the solution is. Best of luck. That's the whole entire lesson, all right? It's just piggybacking off of 6.3a. Your work for this is 2 Khan Academies, an IXL, and then your mastery check, the last one before review.